Hello, everybody. My name is Melina Alexiadou. I'm a science teacher, and I'm going to present you a lesson plan that refers to the calculation of the perpendicular bisector. I'm going to share my screen. Okay, let's begin. This lesson plan was made by our team. The team members are Maria Gounaropoulou and Magioladidis Marios, that are both math teachers. This lesson plan refers to students that are between 12 and 15 years old. Their grade level is the second grade of high school, and the subject of the lesson is mathematics and geometry. Let's begin with the first scenario, because as we said in the previous presentations, STEM lesson plan has to do with real life problems and problems that our students are called to solve them. So the first scenario that we're going to give to the students is that we have three families, family A, B, and C, that doing camp, and they want to put a shower in the middle of their tent, so to have access, direct access, all of them to the shower. And we ask for our students to solve this problem. In order to solve it, sorry. In order to solve it, we ask them to draw lines and find the middle of each line, and then connect the middle of those lines to the S point, and this is the point that the shower will be placed. Sorry. Okay. The explanation is that we find the points of the perpendicular bisector that are equidistant from the edges of the corresponding segment. The common point is in the center of the circle that passes through those 3 points. The circle, of course, is circumscribed through the triangle A, B, and C. The second scenario that we're going to give to the students is that a local artist make a donation to our school and gives a statue. So we ask from the students to calculate we want the students to put this statue in the middle of our local park that is nearby to the school. But we don't know the center of this circle. So we ask them to calculate where the circle is. We make, let's say, the same calculations. We draw lines between the 2 pair of benches and mark their midpoints. Their midpoints are E and Z. And then we draw the perpendicular bisector at E and Z points. The meeting point is where the statue must be placed and the center of the circle. The objectives of this lesson plan are we want from the students to be able to discover and understand the meaning of a line segment, estimate the means of it, and draw the perpendicular at this point. We also want the students to understand the basic property of the perpendicular bisector. And we want from our students to use mathematical knowledge in real life and understand where this knowledge can be applied. So the basic theorem is that all points of the perpendicular bisector, and only these, are equally far from the edges of the straight section, as you can see here. So the central axis of this lesson concerns knowledge that young students are normally familiar with, and we want them to build a proper theoretical basis. And we ask from the students at the end of the lesson to propose other application of this geometric topic in real life. The materials we're going to use are all written in Braille or printed in font Bold 25. And the experimental materials are embossed with PF printer. And also we have some materials 3D printed. And also we use simple tactile geometrical instruments. Here we can see the materials that enable print for us. Okay, thank you, Enable. The methods we're going to use for this lesson are experimental activities, brainstorming, and of course 3D printing. As for the design, the lesson plan starts with an experimental activity in the schoolyard. The students, following their teacher instructions, would be able to learn efficiently the right way to calculate the perpendicular bisector in the yard. We divide them into different groups, and we ask for them to take measurements in the yard with tactile meters in order to find the right places. We start, of course, with scenario A. So we put some tents or some objects, big objects in the yard, and we ask them to find the middle of the lines that connect the two tents. The students will then the students go back to the classroom and use the material that is 3D printed and put in this surface the 3 tents and start to calculate the distances in a not so big scale that we do in the yard, and start make calculations by themselves. So we see here the process to find the perpendicular bisector and draw it. As for the scenario 2, we give them a circle from the scenario that refers to the statue. We give them a circle, and the students start to calculate the chords of the circle. We ask them to measure 2 chords of the circle and calculate their midpoint, and then find where that midpoint is in order to find the center of the circle. The results of this process regarding to the cognitive sector are the students will be able after the lesson to recognize the perpendicular line among others, construct the perpendicular bisector, understand if a point belongs to this line or not, and practice all this theoretical knowledge in real-life problems. The results regarding to the socio-emotional sector will be the students will be able to work together, of course. We want from the students that are visually impaired to feel part of the team and be a real part of the team and do as what all of the students does, take measurements, have a role in every process that the students are called to do. All students, of course, will learn how to feel involved and included in the reality of the classrooms. And students understand that disabilities doesn't indicate different learning processes as far as this process involves inclusive materials. We have some proposals for further development. We ask from the students to solve problems related to construction of roundabouts, squares, and etc. We have here an example. We have 2 villages and 2 settlements, and we want to. This is the route of the bus, and we want to put the bus stop in a point in the middle, let's say, of those 2 settlements. So the way to make this happen is again to calculate the perpendicular bisector. Our team members were Angelina Chisargiri, me, Maria Gounaropoulou, Marios Megioladitis, and Dimitris Makris. Thank you for the cooperation. And let's say some words for the Evclidis. Evclid was the guide for this lesson plan. He was a great mathematician. He is called as the father of geometry. And of course, we teach this geometry in our schools. Thank you very much. If you have any questions, don't hesitate. Okay, thank you again. Bye.
Hi, everyone. Now we are going to present you the last of the 5 lesson plans that we created and we suggest that you can use in your own classroom. In this series of lesson plans, we always take care that everything can be implemented for both VI and non-VI students. This last lesson plan is about the concept of cycles and pi, which is a concept that is discussed in almost all grades, in almost all, probably all curricula around Europe and in all countries that are participating in this InSight project. And so what we're going to do is that we're going to give suggestions and ideas that you can implement and always adjust in your students regarding their age. So our plan is the subject of mathematics, geometry, and physics. It combines all this exactly in the concept of STEM education, and it can be implemented in any grade of high school because it's the main core concept of the cycle and the pi. It can involve measurements. It involves the ideas and the definition of diameter, the concept of radius, and of course the irrational number pi. And it can be implemented in groups of students that are mixed, as we did in the previous lesson plans. This means students that are groups of students that are VI and non-VI students. Again, the set of materials you are going to need for this is a tactile ruler, it's tactile protractors, it's some 3D printed models of things we can provide in STL files and 3D printed ready files. We can even provide them printed. It's very easy things to print, along with printed cards that come in different variations, like cards with large text for students that are partially visually impaired, or written in Braille for students that are completely blind, and of course normal text for students who are non-VI. Idea is here also to form groups of people who play and experiment together, and the idea is again discovering the formulas via experimenting. Everything comes from the concept of cycle and of course of the relation between the circumference of a cycle, the diameter, and the radius. And of course, we all know that the diameter is 2 times the radius, and we know also that the circumference, or this means the length around the cycle, is 2 times pi times r, or in a simplified formula is pi times d, where d is the diameter. And of course, as you understand, here we have to, the main idea is to discuss the concept of proportional sizes and variables like L and D. And what we are going to do is to have one of these two variables known and ask the students to discover the other. So we are going to discover the relation between these two, and the idea is to discover the formula that is between the circumference and the radius or the diameter. And in a later stage, we're even going to discover the value of pi, or approximate it as best as possible. So the idea is discovering formulas through experimentation, which is one of the biggest projects in STEM education. And we think this can be implemented in a very nice way in mixed groups of VI and non-VI students. So one of the 3 experiments we suggest is that we have a fountain in the middle, which is a 3D printed fountain, and we are going to ask the students to measure or approximate the diameter of the fountain by calculating the circumference of this fountain. And the idea is, in the first 3D model we are going to print, it will be impossible to use the tactile ruler or a normal ruler to directly measure the diameter, because, for example, the object is huge or the object is irrational in the middle. So it's going to be something like that, the 3D model. So there will be a base which prohibits students to sit and flip it over and measure the diameter of the cycle. And there's also something in the middle that also prohibits using the tactile ruler directly. So what are we going to ask them is measure the diameter using different measurements, the circumference, and from the circumference to find the correct size of the diameter, and then conduct an experiment of how many benches, for example, they can put around the fountain, or how many trees they can do. And this is the idea of approximating the numbers, and this can be easily done and implemented by mixed groups of students, where, for example, the non-VI students can use their hands and tactile rulers to make measurements, and the non-VI students to keep notes. Before proceeding to the next experiment, I can show you the video of Enable, who used to create all these print models, which is really interesting, or to see what is the work done by Inside and the work done by Enable to help Protoporia. And this brings us to the second experiment and the second idea and suggestion we give, and it has to do with the concept of a cart or bicycle, for example, that has to go from distance A to B to distance B. And what we ask here the students is to calculate the number of rotations needed for the car moving from one side to the other. This comes for another lesson plan we had in the past that involves robotics. And the idea here is we want to move the card from one side to the other, and students calculate the number of rotations, which means they have to calculate by measuring the number or the circumference. They have to find the diameter and the radius, which is really interesting. As you see, we took under consideration the fact that to help them make the calculations correctly, there's also a gap here that is used for non-VI students to have the idea of how many rotations are done by the wheel by just touching it. And this is a very nice idea. And again, the good thing with this project is that there can be different approaches in the solution of a problem. They can, for example, calculate one rotation and see what is the distance covered. They can measure around the circumference and see what is the circumference and use the formula to find the diameter and the number of rotations needed, and many other ideas that are included in the proportional variables. And the third concept is about approximating pi. And this also has to be done by providing them a different sizes of discs and ask them to calculate both the diameter and the circumference and then divide. What we expect here is that they get different values that almost all the same at about 3.14, but of course, because of errors in measurement, the values they are going to obtain may vary. And this comes in a very interesting thing, because what we can do here is, after conducting the experiments and giving them all the plenty of time to conduct the experiments, we can start a discussion, which is the most important part during these lesson plans. And the discussion can be around, for example, if they think that the measurements they did, even if they were VI or non-VI, if the measurements they did were accurate, what they felt occurred during the measurements, during conducting the experiments. Another idea is we can ask them if they were to redesign the script by themselves, what would they change? And then this the crucial last question is why they have differences in measurement. What are the factors that affect the measurement? Because as we say in STEM education, what they really have to do is exactly experiment and discover the formula and see what is the difficulties. What is the difficulties from having an ideal formula to applying it and implementing it in real life. And this is a very nice concept they can use and find the solution. And of course, our results regarding the cognitive objective is about for them to understand the length of a cycle according to the radius of a cycle, understand what is the relationship between the lengths of the cycle and the radius, what is the connection between, what is the number pi, about if it's what is a good approximation for pi. But most important for us, again, is the social emotional support, because what we want them mainly to do in our lesson plans is that we want to give confidence to the non-VI students. We want them to work together with non-VI. We want them to create groups together. We want them to be functional, not only as members of a classroom, but as members of a team, as members of society. And we want all students to feel comfortable to work with others in an inclusion education. We want everybody to feel that is involved and included, not only in the classroom, but in the society. We want them to have confidence that they can solve problems, that they have unknown result, and they can work together in obtaining a common result and having a common target, which is really important, because what school is, after all, it's about having strong citizens, regardless if they are VI or non-VI, people who are capable of problem solving, people capable of taking decisions for their life, feeling comfortable about themselves, know their limits, know what are their weaknesses, and know what are the positives, and know what are the negatives, and people who can, with no hesitation, work with others and obtain common results. Again, I want to say that the template we used was created by the University of Fominio, and as you see, it was a very nice job done by Enable for creating these 3D models and making the ideas of the lesson plans to become true. So our team, again, is Angelina Chisarchiri, was the project manager of our group, Melina Alexiadou, physics inclusion teacher, Maria Gunaropoulou, math teacher, me, Marios Magiladitis, who I am cooperating with Protoporia for this project, and Dimitris Makris, who had all these texts written. He is a Greek literature teacher, and this is our group. And we hope that you find all these ideas interesting and you can implement them in your classroom in one way or another. So thank you very much for attending this seminar about the lesson plans we suggest, and of course we will be here to answer all questions, and of course, most importantly, see if you ever implement these lesson plans, what was your feedback and what was the ideas you got and how you modified these experiments and lesson plans ideas in something different, and what were the results and what was the good practices you used and you obtained from this. Thank you very much again. I got a question here, but it was so yeah, I got a question about if I practice these lessons, but it was in direct message, probably by mistake. I want to say that because I work with robotics, I practice similar lessons with this by asking the students to calculate the distance a robot has to cover using a different kind of wheels. So this is the idea, is a similar concept, but the idea is that we adjusted this lesson plan for non-VI students using these cards and the 3D printings made by Enable. And I also found one of the photos of Enable. Maybe I can share it now. Because we are now recording, so it's easier to see. And this is the fountain I was describing before. And as you see, the interesting part is because we want to simulate the real life problem, Enable created a base here. So to prevent students flip it over and measuring the diameter of the circumference from the other side. So no cheating is allowed. This is the main thing. And the main feedback we get from this, what is the really important part of this fifth lesson plan, is that there are different approaches in the measuring, which is really amazing. You can see people measuring using the tape around the wheel. You can see people measuring, leaving the cart moving, making a full cycle on the ground and measuring the distance covered. You can see people really measuring the diameter. There are different approaches in the measuring. One of the most interesting parts in the STEM is also people doing it by really experimenting, right? Really moving the cart and and calculating the rounds taken by the cart. So these different approaches really are the biggest part of what we call STEM education. Sorry, Angelina, for interrupting, but I had to ask.
No, that was not an interruption. That was what we're here to do. Any more questions? No. Do you feel confident in teaching with these lesson plans? Do you think that you can make it? Would you need something more? Okay. So if that is all, maybe we can sum this up. And sorry, I have a question, I think. Okay, people are facing problems with internet, okay. Good. If that is all, maybe we can close this meeting. Angelina, do you want to add something to the group?
Well, not exactly, I mean, but just in case that you reach at these lesson plans again and you have any questions, we will be very happy to give you any clarifications. So don't hesitate to ask or email us or send a text contact through the website of Inside. I think that when someone gets the lesson plans and implements them in the inclusive classroom, then it will be easier to understand it and maybe add something, or don't use something else, or many more ideas could give birth from a lesson plan. But for us, from the position of the project manager and like the member of the scientific team, I would like to say that this was a very interesting process, very creative. It was built in a good team spirit. So that's what STEM is. I mean, it's not like one science, but more than one science is combined, and that's what makes it interesting and challenging for the students, and of course for the teachers themselves. So thanks again to Enable Greece for making our ideas come true. Okay, thanks for the collaboration. Thanks the members of Protoporia's team, and of course all the participants who were here with us today, and could see how these STEM lesson plans came true. I mean, like the idea, how from the idea it went to the action.
Good. I'm really sorry again for the missing recording. I hope we can make something happen with Protoporia, so you can have a video of these presentations. I have already uploaded in the chat room the link for the evaluation form. Yesterday, I think we sent you an email that attached the file with all the links of the evaluation forms and the questionnaires from the previous webinars. So please, if you haven't done it already, fill out these forms and the questionnaires. It's really important for the evaluation of the project in general. I think that is all. Have a good night, everybody, and we will see you again in 2 weeks. Okay?
Good night.
Good night.
Καληνύχτα.
Bye. Good night.
Yeah.
Bye
Night,
bye everyone.
all.
Bye bye. Good night.
Bye. Καληνύχτα.